5-inch mini quad shootout, I'll be conducting some thrust tests of various props that I've purchased here. I have a range of props from different manufacturers, as well as different number of blades, 2-blade, 3-blade, and even some 4-blade props. And they are also providing different pitches of the blade, as well as bullnose and non-bullnose variants. So I'll be testing these. All of these are 5-inch props, and I'll be testing them on a thrust stand with the 2206 2350 kV luminaire motor and the 24 amp KISS ESC. Those are the components that will be part of the running gear of all of the quads. So really I'll be looking for two factors here: current draw versus thrust. I don't want to exceed my 24 to 30 amp current draw, but I want to achieve maximum thrust. Here is the equipment that I'll be using for the thrust test. I have a thrust measuring stand here which measures the thrust in grams of each propeller while hooked up to a common motor ESC combination. The flight batteries that I'll be using are these Turnigy graphene 1300 milliamp hour 4S batteries, but they're no good for doing a thrust test, and the reason is that they'll suffer voltage sag. And because motor RPM is directly related to voltage, a lower voltage means lower RPM, and that relates to, or that then results in lower thrust at the propeller. So I've set up the LiPo equivalent of a nuclear power plant over here. I have 6 4S batteries hooked in parallel, so 6 into 2 into 1 here. The output voltage is 16.8 volts 4S, which then means that I have a reserve capacity, or a capacity of 30 amp hours, or 30,000 milliamp hours. So I don't expect to see any voltage sag with this combination. I should be able to consistently deliver 60 amps if required through this connector and experience very little voltage sag. Now, connected up to that will be this Turnigy meter which measures the current draw and also the battery voltage, which then can be converted into watts. So that'll show me how much current is being consumed, or how much current's going through, and therefore how much power is being consumed, and allow me to monitor the battery voltage. Here I have the luminaire 2206 2350 kV motor. This is what will be fitted to all of the quads. It's a brand new one. It still has the little bullet connectors on it. And here is the 24 amp KISS ESC I'll be using for the test. I've put some female bullet connectors on here which will allow me to easily change motor direction. I know I can do it with a solder bridge, but a bit easier just to change the wires over, as well as to use this later on. I'll leave it like this, and then I can test other motors and prop combos in the future just by plugging them in. I have a battery lead on it which will connect up to the other end of this, and I have a servo lead for the signal and ground wire there. Also notice I've fitted a capacitor to it, a low ESR capacitor. Flyduino recommend that if your battery leads from the battery to the ESC exceed 20 centimeters, that you need to use a capacitor. So I won't be using capacitors on the mini quads because I expect to have shorter battery leads, but for the sake of this test and to ensure that it's I get the right results, I've fitted a capacitor here. I do have a servo tester here, which I've used in the past, but it's given inconsistent results. I get a lot of stutters at high RPM or high PPM output, and so I won't be using that. Instead, I have a flight controller. This is an old Naze Rev 1 flight controller, and what I'll do is I'll hook the ESC up to this and connect that through a USB cable to the PC, and then I can use the Clean Flight Motors tab to increase and decrease the PPM and effectively control the speed of the motor. It'll also allow me to see exactly what the output is and to dial up a half speed or half throttle output, 1500 ppm, and therefore I can check what my thrust will be at half throttle without having to guess where halfway is on one of these dials. I'll be doing the thrust tests in the garage with the thrust stand securely bolted down, but it's a bit easier in this environment just to show you all the parts connected together. I have the motor with its prop connected here on the thrust stand. I have the ESC hot glued down to the base by its capacitor. This is just in a position that roughly simulates how it would be on the arm of a quad, with airflow to run across it to offer some cooling. The power from the batteries here runs through this meter and to the ESC, and the ESC signal and ground wire here, I've put an extension on that to bring it to this flight controller, which via USB cable is connected to the PC. On the PC I have Clean Flight running and the motors tab open, and I'll just tear this and run the motor up just at very, very low RPM. I don't want it taking off on me. I can use my mouse to increase, I can even use my arrow keys here just to go up by 1 ppm increment. There we go, 1150, very low RPM. But what we can see is 48 grams of thrust being produced. And on this meter here, the current draw is 0.34, 0.35 amps at 16.8 volts. That equates to 5.7 watts of power. And here I am, set up on the table in the backyard. Let me run you through one of my tests. This is for the Gemfan 5045 tri-blade non-bullnose prop. And I only experienced about 0.2 volts sag for all of my tests, so gave very consistent and comparable results. Here's the table of results, and you'll see that there's a grouping over to the right side of the chart. I think that's where I found the current limiting capacity of the KISS 24 amp ESC. Some of these props might have produced more power, but not with this ESC. The prop that produced the most was the HQ 5x4x3, represented by the teal or schizo coloured triangle at the top there, with around about 1150 grams. Its Gemfan equivalent 5040 tri-blade produced just under 1100 grams of thrust, but used 3 amps less current to do it, so another standout to me. I was a bit surprised by the bullnose tri-blade props. None of them performed very well. The 4-blade HQ did perform pretty well, but wasn't a real standout either. From the results, I wanted to do some further testing to understand if a more efficient prop could ultimately achieve better results over a 10 to 15 second punch out. So the Gemfan prop produced 1097 grams of thrust, drawing 23.5 amps, consuming 387 watts of power for an efficiency of 2.8 grams per watt. The HQ, on the other hand, 1144 grams of thrust, 26.3 amps current draw, 434 watts power consumption, efficiency 2.6 grams per watt. So I don't have a 30,000 milliamp hour battery strapped to the bottom of my quad. I've got a 1300 milliamp hour. So this reserve was able to ensure that I only experienced a 0.2 volt voltage sag for the sake of the tests and could get comparable results. But in reality, I'm going to have 4 times the number of prop motors pulling amps out of the battery, and a battery that's 20 times smaller. So my test rig has grown. I've still got my original thrust stand here. It's measuring the thrust associated with just one of the motor prop combinations. And so similarly, the watt meter or current meter is also only connected in line with that single one, but the battery voltage is shared across all 4 prop motor combinations. So they'll all experience voltage sag, but I'll be measuring it associated with one. The old motor that was fitted here has been moved to over there, and a brand new motor 2206-2350 fitted to the thrust stand now to ensure that I get consistent results. And new motors fitted down there, one missing a prop. So the next part of this required me to have a flight battery, so I chose this Dynegy 1300 4S 65C battery. It's relatively new, it's only had 4 or 5 cycles on it, and I'll recharge it and let it rest between tests. I ran the test twice for each prop to ensure that I could get consistent results, and I did. Now I averaged those results, and here they are for the 2 props. The HQ produced more thrust all the way through for the whole 15 seconds. I was expecting it to dip down below the Gemfan at some point since it was drawing considerably more current. On average 12 amps more current across all 4 props. But it didn't, it stayed above there, and it produced about 5% more power through the 15-second run, but it used 8% more power to do it, so perhaps slightly less efficient. There you go, that's the comparison of those two, and now I'll move on to another comparison I decided to do between the Gemfan and HQ 5045 bi-blade bullnose props. And these actually tracked very similar. There you can see the results, but the HQ consumed quite a bit more power to do it, so definitely not as efficient as the Gemfan. And now to summarise the thrust testing. I'm confident that I've been careful and consistent with my testing to produce comparable results, but there's one attribute I can't account for, and that's airspeed. The props on a quad travelling 100 kilometres an hour or more are going to be performing differently than they would on a test bench static in my backyard, so I won't know until I get to the field. What I have decided is that I'll use a 50-40 tri-blade prop, either the Gemfan or the HQ, for the acrobatic flights as well as probably the racing tests, and that I'll use the Gemfan or HQ 50-45 bullnose 2-blade prop for the high speed testing. Anyway, stay tuned. Battery testing is the next part of this shootout, and then followed by the builds. Stay tuned.